Testing, 1, 2, 3. Testing, 1, 2, 3. Okay, ladies and gentlemen, let's get to it. It's good to see you. Thanks for joining us for another 498. How many of you have started the project, homework 3? Okay. Have any of you gotten 100% on one of the categories, one of the platforms? All right, you don't count. The rest of you, very good, very good. Okay. If you don't have that, you're definitely not behind. Okay. If you haven't started yet, anyone admit to not starting yet? Okay, that's actually the assumption. Okay, the assumption is you haven't started yet. Today, we're going to give you a bit more of an intro. I'm going to do some programming with you today, if we have time. And we'll talk about some very pragmatic C++ concepts. We'll talk about how to use your IDE. We'll talk about the homework 1 and submission process to the autograder. And we'll do a little bit of programming together. Okay, should be fun. A couple announcements. Actually, let's look at the schedule first, right? You can see right here, you look at the schedule. We are kind of right in the middle of that homework 3, okay? Homework 3, not super hard once you get going, okay? It can take a bit of time to get the autograder situation figured out, to get submitting, to get things building. It looks like some of the students who are on Mac OS X, how many of you are mainly driving on OS X? It looks like some of the people who've been using OS X have gotten through and have gotten things building, but it looks like if you used a really new version of Xcode, then the autograder is like, what is this? I have no idea what you're doing, and that's a bit of a problem. So I think tonight I'm going to go update the version of Xcode used on the autograders. That's going to be really scary. Okay, Xcode just trolls me. That's all it does. But hopefully it'll start working then. And if it doesn't, all of you are getting a bunch of free points on the homeworks until it does, right? So anyway, look forward to that. If you are not getting your OS X version to build on the autograder, remember, you can proceed with Linux and Windows if you want, and you can knock down the test cases and then come back and submit again for OS X, okay? I know it's a bit annoying, but yeah, welcome to the bleeding edge, right? Not too many people making game engines on their own, but we'll get it figured out, okay? All right, so let's go ahead and take a look at here. I want to show you a fantastic game engine. This is kind of a very unique and well-known game engine. It's not used for a bunch of commercial products, but it is used heavily in the prototyping and game jam community. Pico 8 is what happens when you take two of our categories, the minimalist engine and the integrated engine, and you somehow make them have a baby, and you get Pico 8, a minimalist integrated game engine, okay? That uses limits as a feature and not a bug, okay? How many of you have played a game called Celeste? Okay, very well known, very popular, very polished 2D platformer. So we're going to play it together. Are you ready? Because this is the Celeste that you remember, right? Let's take a look. Right, you played this one, right? Yeah, yeah. X and C. Okay. Okay, there's Madeline and Jump and Dash. Okay. Right? Look familiar, right? Yeah. One of my favorite parts of playing the final commercial Celeste game is the final stage where you start getting the same height banners before every little section, right? It's like, oh my god, it's the prototype, right? You can find this prototype in the Haunted Mansion or the Haunted Hotel or whatever it is. Okay, cool. I'm not good at this version. Anyway, this is made in Pico 8. It was made very fast, I think. It was made in a quick game jam game. Does anyone remember how fast that game jam was? It was something, yes.
48 hours.
48 hours. Woo! All right. And then you spend the next 48 months making the full version, okay? Anyway, Pico 8 was initially released in 2015. It was made by a fella named Joseph White in Tokyo. And he has a great talk on kind of the creation of Pico 8 that you can enjoy here. It's $15, so it's kind of a unique business model, kind of RPG Maker style, except cheaper. And it has a free web-only EDU edition that you use in your browser, okay? So you go to that website, and Pico 8 EDU, and you click on the play button, and we have Pico 8, okay? Now, you can download things to disk. As far as I know, it's a pretty, fully featured version of Pico 8. You can use it to really do some stuff. You start with this command line, using temporary disk, right? And then you run help, and it kind of gives you some ideas on what to do. And I always forget. Oh, you can press escape to go from the terminal to this kind of editor view. Now, if you're used to Unity, right, this is your integrated editor view. Look at it. Behold it. Okay? It doesn't look the same, does it? Well, this is the code editor. And if you click on this icon up here, you've got the sprite editor. Okay, so I can draw like a little sprite. A happy face. No, Control Z, happy face. Winky face, I think. This is the map. So now I can put as many winky faces as I want. I think I can also draw... Can I draw another one? How do I draw the next thing? Oh, I click over here, and then I can draw the sad face. Okay? And I can come over here and have a new tile. So this is kind of a combined text editor, tile editor. We can even do musical stuff, right? I think you've seen a lot of this, actually. Did we talk about this? I think we talked about this, didn't we? Yeah. How do I play this? Did I press space? Is that juicy? Oh, yeah. Right? The sound effect even looks, the way it sounds and the way it looks, there's this connection there that's really fun. And I think you can then take a bunch of sounds you've made, kind of like the tile editor, the map editor, and you can kind of put them on here to make music, right? So pretty impressive stuff. The engine is actually written in Lua. I forget what the lifecycle functions are called. Do you know?
Underscore init, underscore update, underscore drop.
Okay.
You have to say function.
Yeah. I'm forgetting my own Lua stuff. I haven't written Lua for quite a while. And then it's do, right? Do I put do up here? No, end. I put end right here. There we go. I'm going to rememorize all this for the Lua section of the course later. But anyway, you've got some lifecycle functions. You can write code in here. You can't fit too many characters per line. Oh, I guess you can do this. But it's minimalist, right? It looks like there's a maximum number of lines you can actually have in your program, which is crazy. Oh my gosh, you've got a maximum character count too. So the restrictions and the limitations here are actually a huge feature, most people say. It forces you to really focus, right? You're not going to make an MMORPG with deluxe 3D character models in here, okay? You're going to be forced to focus on your game's design and then what really matters, which is really what a lot of people love about Pico 8. So anyway, 128 by 128 resolution, 16 colors. In a sense, just as opinionated as a game maker, but a very hardcore constraints, okay? It has a lot of great tools, Lua editor, sprite and backgrounds, audio editor, it's good stuff. One really cool thing is that if you actually make games, you can actually distribute these games by encoding them as PNGs. So if you make a game, you program it all, okay, and then you save it to disk, it's saved as something like this, a PNG. I think it's called steganography. Has anyone heard of steganography? It's this technique, maybe you talk about it in EECS 388, in which you basically hide data within images, or you hide things within images. So this cartridge is super cool, but inside of it is also all the information you need to actually replicate and make the game run. So you can load this cartridge, you can send it to friends, they just load the cartridge up and it works, right? Incredible, incredible. So you can click on this link if you want to read about how that works. I've kind of forgotten how it works. It's written in C, not C++. Okay, we use C++ in this course. They're a little bit more old school. A lot of people really just like C for its simplicity. It doesn't have a lot of the features that C++ has, but a lot of people, again, the kind of people who would make Pico 8 are going to look at C and be like, that's great, okay? It can be compiled to WASM via mscriptum, right? That's what we were just doing, playing the web build. It's just really impressive stuff. They got Windows, Mac, Linux, and web builds. Very impressive. So Pico 8, for your next game jam, consider it, okay? It is very impressive technology. And just keep that, you don't have to subscribe to it, but keep that notion in your mind, in your heart, that sometimes less truly is more, okay? You can't always make something better by adding onto it. Sometimes you have to just make really, really good choices in a minimalistic way. All right, so I started this Twitch stream. Big announcement over the weekend. This is something that consumed my soul over the weekend. If you go to EECS494 or EECS498.com, you'll see that something has changed. There are a bunch of more courses there. Now, 2 of these are just courses that already existed and didn't used to be there. But now there is a new course. What is that one? EECS 298, 3D Technical Art and Animation, okay? And I got to tell you, I'm very, very tired. I'm not feeling super good. And part of the reason is that I'm dumping all my time to making this new course. So this is a course that hopefully you've been hoping for a while and asking for. I think some of the art students have been asking for it. This is our Blender course. Okay, this is our 3D animation and modeling Blender course where you get to learn Blender. You're going to come away with a deluxe 3D platformer completely arted by you. What does that mean? Well, you're going to get a Unity project that has this technology. You won't have to write a single line of code, but what we will have to do is bring it to life. You'll have to create the characters from the ground up. Here, this character is not from the ground up. I did not design her. This is Princess Peach. This is one of the first characters that you will animate and rig and bring into the engine. Why? Anyone know? Anyone know what's really nice about a character with like a gown that obscures the legs? Yes.
She has no feet.
That's right. So the animation, the run animation is super easy. You know who the second character is going to be? And I'm working on him right now. It's gonna be. I just posted this footage. It's gonna be Rayman. Okay, why is Rayman super nice to animate as an early character to animate?
No arms.
No arms, no legs, no limbs, no problem. Okay, now harder than Peach is because when you go to do the running animation, which I'm animating right now at home, you still have these pieces, right? You have to get them kind of lined up with all the keyframes and to look good. One cool thing about Rayman is that his mouth is actually built into the geometry. That's not always the case. So if you look at Peach up close, her face, much of her face is actually a texture. Okay, so if you want to make that animate, it's a little bit weirder, it's a little bit trickier. You have to swap the texture out and back in. For Rayman, we can just create a skeleton, a bone that comes out of the mouth, the bottom part of the mouth, and then another bone out of the nose. And we can animate those bones on the armature, the skeleton, to get this really cool effect where it looks like it's a wow. Right, and then he goes back to being bored when he's done with the animation. Anyway, so that's going to be in the game soon. Anyway, what's going to happen is everyone's going to art up their own characters, their own environments, their own 3D stuff. You're going to end up with 30 plus models that you created, geometry, materials, rig, all that stuff. And you're also going to have a good, playable 3D platformer working in the web with multiplayer by default, okay? Like what you currently see. So anyway, you're going to also do environments. So here's my little crappy tree that I did in like 10 minutes. It's a very hard to climb tree. Good luck if you want to climb it. But you can see, if you've ever used Unity or Unreal before, it's really hard to make kind of organic, surprising shapes like this in the engine itself, right? Blender really makes that possible. So the first half of the course is let's get really good at Blender so we can make our own characters from scratch. We can make good animations, idle animations, right? But also running animations and jumping animations and victory and defeat animations and stuff like that. Then let's spend the second half of the course bringing it in to Unity, okay? Getting it working well, getting it running around well, the characters reacting dynamically to things around them, characters blinking, the animations playing at the right time. Let's get the hair physics working. Let's get special effects in the environment like flowing lava, okay? And the mission here is that suddenly your portfolio looks way better than it used to, okay? And all of your future projects look super good. So anyway, please let me know if you have any feedback on the course. We're designing it right now. I'm super excited about it. Hopefully a lot of people take it so it doesn't get canceled. Yeah, let me know, okay? All right, so enough about that. By the way, this is probably going to be Flex Tech. I hope I can get that credit type for you. And 4 credits, okay? Moderate workload. So you can probably pair this with a 482, but not like a 482 plus a 485 plus a 492, okay? Be a bit careful. Okay, and this is coming next semester. So quick questions. How did homework 2 go? How did it feel? One thing that's tricky about homework 2 is that's a lot more, and sometimes that starts to burn you out, right? It starts to feel a bit repetitive, I think, in some cases. But spending that time in these 3 different engines, being asked to do a bit more, right, gives you a better feel for what engines do, what is expected of them, and how they differ between each other, right? Yes?
It makes you very appreciative of features of the system that you use.
Yeah.
And very questioning of why everybody's replacements and not complete copies don't exist.
Yeah, right? So maybe the collider system in Unity really resonates with you. Or maybe, if you're like me, you're like, this was easier to program myself in the minimalist engine. These colliders are nasty, right? So you get this feeling that just giving me more features is not always the best thing, right? Those features have to work well. They have to be easy to learn. Integrated engines are not cheap, right? In time or sometimes even money. So, yes?
I completely agree with you. I had so much trouble getting my colliders to work. I feel like it took me like an hour just for whatever reason just to get my colliders to work.
Yeah, Unity tries to give you all these features and tools, but like any tool, you have to spend some time to learn it, right? Before it's going to be super useful to you. So, but a minimalist engine, a lot of people love it because everything in that engine is going to be something you wrote. So you're going to understand it. You can write only the things you really need. So anyway, pretty cool stuff. I've got a couple of games to show you real quick. And there were a lot of awesome games, and these are just a couple I grabbed in just the last few minutes. I really love this. Anyone do the IRL cat? The cat. Who did that one? Very, very good. I absolutely love it. I think we get a meow sound effect, right?
You get hurt, yeah.
Oh.
You get victory, and then you're going to get
Meow. So the cat, what's that cat's name?
Her name is Marmar.
Marmar is sleeping, and if you get hit too much, you wake up. But if you defeat the clocks, then you get to keep napping and sleep in, right? Super cute, great theming, well done. Sequel to a 494 game. Let's see here. Okay, Noah, you're in here, right?
Yeah.
Yes. This is a sequel to one of my favorite games from 494. I think this was last semester.
Which version is this?
This is the second one, right? I think.
I know, but is this Love 2D or is this Unity?
This is the Unity shmup.
Okay.
Okay, so here goes. I have no idea what this is.
You can actually see it in Love 2D version.
Oh,
You
okay.
actually play it.
Oh, got you. Okay. Okay. You're throwing baguettes at ducks. You're a guy who's an old man who's at the park feeding ducks as they walk up. Okay. It makes sense if you saw the prequel game. The Five Nights at Freddy's yay sound. Very good. Okay. And then a Pico 8 vertical scroller. So this had a vertical movement scheme, which was a little bit more rare. I feel like the bullets are slightly off to the right. Let's see. BOGS. Are you in here, BOGS? No? Okay. All right. Hey, super cool stuff. Love the aesthetic. And good job, Pico 8. Okay. Unfortunately, no one used Click Team Fusion, I don't think, this semester, so I'm very sad. The FNAF engine is not it's a very lonely engine. Okay. I'm gonna have to start offering extra credit for people who choose it. Anyway, some quick notes. The commit messages are looking a little bit dry these days. When I go and check on your repos to see how things are going, I'm like, oh, yeah, great, wonderful, right? And I can't tell at all. Reminder, right? You can put this string anywhere in your entire message, commit message, so you can include other stuff as well. And I recommend you do that so that you can find stuff. You can find stuff. So this is from last year. This is not from anyone in this course, but you'd be, I wouldn't blame you for thinking it was from this year. Yes.
Specifically, you can literally, you don't have that be the title of your commit at all. It can be in the description, and then your title can be something more descriptive, like test suite, for
yes,
yeah, or that.
Yeah. By the way, I found this recurring bug where students were accidentally putting a space between homework and 3. And I was like, oh, fine, okay. And I went in and fixed my regular expression to go in, and now it can do both, okay? It can do both. You should be fine. So hopefully I'll never get that issue again. Okay, a cool documentary on renderware. If any of you played a lot of games in like the 2000s era, Sonic Heroes, Grand Theft Auto, this is the engine that powered a lot of those kind of 2000s era games, multi-platform games, before Unity became a big thing. Okay, renderware was made by Criterion, the creators of the Burnout series. If you like those games at all, from Electronic Arts. When EA purchased Criterion, the Tony Hawk games, wow, right? When EA purchased Criterion, they made a big hubbub of how, renderware is going to be the next big thing, and then they killed it. Now EA has the Frostbite engine that is still going strong, from what I understand. But renderware, right? Very classic. Hey, there's our guy. Okay, Rayman. We just saw him. I don't think it's the same model, though. Anyway, so cool stuff. You can check that out if you want to. And now, for those of you who are working at Homework 3, really quick, how's that going? It's going okay? We had a student who finished all 3 platforms 100% on Sunday night, before I even released the assignment spec. So I'm thinking, how did you get the assignment spec? Well, you can get it through I put it on the schedule a bit early, and you can also get it through the syllabus if you look closely, okay? So it's always a fear of me of like, okay, something going to be broken, like maybe something will block students from being able to finish it. I'll have to rush to the office and debug and stuff. So that's a really good thing. The first person to finish a homework assignment always makes me feel really, really confident. However, as a quick PSA, people with newer versions of Xcode that you're using, it looks like you're having issues building on the autograder. I'm going to try and fix that tonight. We'll see if I can. Otherwise, we'll just give you full credit for the Mac portion of Homework 3. So we'll see how it goes. Get started as early as you can. Definitely start tonight if you haven't started yet. It's not a super hard assignment, but it takes some time. Okay. All right. Very good. Very good. Okay, so what I want to talk about today are pragmatics, all right? And the first topic I want to talk about is something that'll be really important as we move on to homework 4 and 5, okay? This is the topic of the compilation process. And this is something that you might be struggling with a little bit as you start to get into using dependencies, okay? When if you know, on homework 3, you are required to go and you're required to get a dependency. What is that dependency? Does anyone know? Which one is it? Yeah. That's right, GLM. And we ask for GLM in particular because we want to standardize some of the ways you do math. And we want to give you some nice data structures to help you with this all. So when you go through most of the auto-graded homework assignments, you'll get a spiel, okay, on what the assignment is trying to do, why it exists, what you're supposed to learn in it. But then in this task section, you'll find a lot of things you need to do. In particular, you'll always find the auto-grader general guide and specific guides to help you build on Windows, Mac, and Linux. You're encouraged to read through these if you can, and if you start having a big issue with one platform or another, then you should go to that specific one, okay? This has a lot of stuff in it, a lot of information for troubleshooting, trying to get stuff working, and so it might help you out. You'll find this Acquire Assignment Dependencies task, and you'll see this box that tells you what you need. It'll even point you to the version you need, and it will usually tell you kind of roughly how you should integrate it, okay? Maphelper.h is some custom code we wrote for you, and you've got the gitignore, but I think your repos already have that. The autograder puts that in for you during this semester, okay? All right, so you'll eventually get to the test-driven development part, where you'll get a test suite with a bunch of hints and tips about what you're supposed to do, and I recommend not moving on to the next test suite until you've completed most of the tasks from the previous one. The final test suite, okay, has performance tests. It looks like people aren't struggling with these. Again, on homework 3, super easy performance tests, so not too bad. But this compilation process is going to get nastier and nastier, okay? In fact, on homework 5, many people said that the hardest part of the homework was just getting SDL to build. Okay, getting it to link properly on all 3 platforms was a bit of a doozy. It's going to be easier this semester because I'm going to record a video showing you literally what to do on each platform. But the compilation process is something that you probably want to spend some time thinking about. Okay, it is fairly interesting and it's also extremely relevant. Let's talk about some really positive things when it comes to kind of setting up your IDEs, getting that compilation process working. If you look up here, you can see, right, that when you have your IDE working for you, you get a lot of excellent features. Perhaps the best is syntax highlighting and code completion. The idea that when you have a certain data type, a certain token, it's going to kind of hint to you at what that is. So if you see a green color, for instance, that is telling you, hey, you're dealing with a class, all right? With code completion, when you start typing something, it will help you finish. When you press dot, it will show you what is available to you in terms of functions. When you get a new library, often code completion is the only way you're going to figure out what is available to you, okay, and learn that library. Here's a big one. One of the reasons that you fail a lot of test cases in this course is due to something called undefined behavior. In C++, what can happen if you forget to initialize a variable? This is something that could have happened to you in EECS 183 or 280. You're always told to initialize your variables. You create a new variable, give it a default value, right? Why do you do this? What's the point? What can go wrong? Yeah.
You don't dereference something that's just null memory.
Yeah. it could be null memory, or it could be a garbage value, right? If you just have a variable int a, and that's it, right? That variable, when the program starts, might be something you do not expect, okay? And that can mess you up. In this class, in general, if you auto-grade your homework twice in a row and you get different grades, there could be a performance issue, but it could also be an undefined behavior issue, okay? Especially if it's a correctness. You're failing a test case 50% of the time. That means that maybe you've got an uninitialized variable. The warnings you're going to see in your IDE, you want to turn them on, you want to pay attention to them, okay? These are going to point out when you might have variables that are uninitialized, or you might have undefined behavior. The warnings will say basically, hey, this ain't going to go the way you think it's going to go, okay? This probably isn't what you want. So you want to prevent those from becoming too many, okay? You can have undefined behavior in this example, for instance, that will blow you up for a while, eat up your time, okay? And lead you on a wild goose chase, all right? One also interesting thing is embedded AI assistance. When you go and you start programming, when you start editing JSON files, sometimes these modern IDEs will actually give you hints about what you might want to do. And that can save you a lot of time and a lot of pain if you're editing things just by hand, as we'll be doing quite a lot. Okay, you can also get embedded version control features that can help you kind of get things pushed and committed faster. It can help remind you of things you've changed, all right, if you're doing experiments and you want to get rid of them or you want to keep them, all right? But what we're really here to talk about is how this blows up in your face, okay? These tools, these IDEs, these compilation processes are very spooky. All right, they're very scary in some ways. If you're not used to using these IDEs, then you're gonna find this to be a bit of a heavy thing. Okay, especially Visual. Well, Visual Studio is pretty good. Make is super simple. Visual Studio is getting there in complexity, and Xcode is a nightmare of UI and user unfriendly stuff. Okay. All the Apple fans out there, I'm sorry, but the reviews back me up. I'm going to show you that in a sec. In Visual Studio, you will have to answer a bunch of questions. You'll have to tell Visual Studio, hey, where are my header files? Which ones do I want? Where are my libraries? What should I do with my DLLs? Where should I copy them to? Okay, there are a lot of questions you have to answer to get that build process set up. And we're going to teach you how to do that. In Xcode, right, you're going to get, and Visual Studio, you may get some errors that are a little bit crazy, okay? You will have to be able to figure out what these errors are telling you. They're hard to understand, but in general, if you can understand what they're saying, you can move much faster. You will also just get a ton of crashes, all right, when you use these pieces of software. It's going to happen, okay? You might say to yourself, well, I'll just use Vim. Okay, and it'll be super nice. Let's go, all right? Make file, super simple, all right? And your Linux build at least is working. And that's not a bad way to go. I'll tell you, though, that almost everyone in industry, in game industry, they're not using Make, okay? They're almost always using Visual Studio. On occasion, you see Xcode if they're doing iOS apps, okay? But Make is not seen that often, at least from my experience, okay? But here's something to think about, all right? So not all changes are made equal, all right? When you're attempting a new personal best versus maybe you're trying to find a gym pass that you lost track of, right? These are two challenges, but they're not the same. One is much more satisfying and beneficial than the other. You grow much more from the other than from the former, right? From the latter. So if you think about, right, the challenge of reaching a new multiplayer rank in your favorite game versus getting the game to stop crashing, one of these challenges is really satisfying and interesting, okay? The other is not, all right? If you think about adding a new feature to your engine, right, that's a pretty unique, nice, satisfying intellectual challenge, right? Versus the challenge of just getting Lua to compile and link correctly, that drives you insane, okay? I have a question. How many of you have lost an hour or two to just getting the autograder to build your thing? And riddle me this, how satisfying is fixing that? How, as you butt your head against that, how much do you feel like you're learning, right? Not much, really, not a ton, right? And that makes it horribly unsatisfying. It's not fun. That's why we have guides and we try and help you out to get that going fast. How many of you have spent a few hours actually reading the assignment spec, right? Relearning C++ and doing and knocking down test cases, right? A little bit better, okay? A little bit more satisfying, probably, all right? Right? These challenges are not the same. On the left, you've got knowledge gain. You're making an impact, okay? Even just attempting to move things forward is really fun, interesting. But over here, you've got problems that are just a waste of time, okay? They don't really give you much knowledge, and this really saps morale. So the mission here is that we want, in this course, we want you to spend most of your time on the satisfying, interesting stuff, okay? And the more interesting the challenge, the less guidance we're going to give you. Okay, when it comes to building, when it comes to getting things linked, okay, headers included, built on the autograder, we're going to provide you as many guides as we can. Okay, compiling, linking, and running. You've seen these before. If you look at the spec, they're here to help you. We'll be adding to it more. All right, but when you come to these IDEs for the first time, Xcode, Visual Studio, and Make, it's going to feel like they're very different from each other. The UI experience is dramatically different, okay, across all three. But what you're going to discover is that they are all the same in the basic questions that they ask you, okay? In the same way that you can learn several different game engines, and at first they feel different, but then eventually they start to feel very similar, right? IDEs feel the same way. Compilation processes, build processes feel the same, okay? So here are the 4 things you need to remember. And if you do remember them, then building your projects in this course will be very easy, all right? Number 1 thing in a C++ project, you must tell your build system where to look for header files, okay? Well, what does that mean? Well, you know when you use the include statement, right? You're trying to bring more source code into your project. You want to use certain classes or functions, right? You need to tell your IDEs or your build systems where to go to get those headers, okay? And in Visual Studio, it actually looks like this. I'll show you this more in just a bit. But if you go into the configuration properties for your project, actually, let's go ahead and make a new project, and we'll do some programming together in just a bit. I'm going to open up Visual Studio, and let's go ahead and create a new project. And let's go find an empty C++ template here. Okay, anywhere, console app. Is there an empty in here? Bingo, there we go. Empty project. Okay, let's call this test project. Actually, let's call this my test game engine. All right. When we create this project, we're going to end up with basically nothing. All right. Nothing in our project. We're going to go and we're going to create something. Actually, let's go to source files. Right click. Let's go to add. I want to add. Should be a new class. I want a new item. I want main.cpp because I don't think it gives it to me to start with. All right. Include. Okay. Include IOStream. Do you know what the difference between this and this is? Oh my gosh, you're killing me. Do you know what the difference is? How many of you don't? So this is one of those things that's easy to forget. But when you're using these kind of carrots, you are asking to include an IOStream file. But you're doing it by basically saying, hey, look at your computer's kind of global C++ install location. So on your machine, somewhere on your computer, the C++ and all of its libraries and files are installed. And if you use these carrots, it's going to look there. If instead you use these quotation signs, it's going to look in your local project, okay? And so, in general, in this course, you probably want to use these for anything you wrote, okay? And caret for anything you got just from the C++ library, okay? Anyway, int main, let's see if we can run this code actually. Return 0, okay, standards. Yeah, I haven't written C++ code in a year, so let's see how this goes. Hello, 498. Let's go standard end line. Okay, run it. All right. There we go. Hello 498. It works out. All right. So once you've got this project kind of going, you can go to, I think, what is it, File and Project Settings or Configuration?
It's under project.
It's under Project. Okay, gotcha. So under Project, and then we can go to My Game Test Engine Properties, and there you can find it. Your Visual C++ directories, and you find an include directory, okay? If you go in and click on this little button, right, you can actually add additional paths right in here. And whenever you go to include a header like that, it'll actually bring it, it will look in those areas. Otherwise, you'll get a little red underline and it won't work out so well, all right? So for make, you have a make file, and it could look something like this, all right? Here, you're telling make that you want to use the C++ 17 standard. This little -i, okay, this little -i basically says, hey, give me a path that I can look for headers in, all right? So in this case, if you try and include anything with the quotation signs, it's going to look in this path, it's going to look in this path, and I think by default, it will also look in the local path, okay, wherever the file is. In Xcode, you've got this header search paths property in your project settings, where you can also specify where you want to look for certain files, all right? So, for instance, if you're trying to use GLM and it is in a folder called third party, right, you might have to include that so that it looks in the right place, okay? One thing that's important is when you're telling your IDE or your build system where to look for things, or when you have any file path at all, really, you can use these little macros, project dir and project _ dir in Xcode, okay? This is for Visual Studio, this is for Xcode, and that will help you keep your file paths working across machines. It becomes a relative file path because if you use an absolute file path, what's going to happen when your project goes on to the autograder? The file system is going to be different. The absolute paths won't make sense anymore, and you're going to break, okay? So when you set things up, make sure you use these project dir macros. Once you've told your build process where to look for headers, you still have a question to answer. Which one do you want? Okay, I know where to look, but which ones do you actually want, all right? Well, this is what you're doing when you write that include statement, okay? That include a line, that macro, is going to actually say, hey, I want to go out and get this particular file, okay? GLM, all right? GLM/glm.hpp. And so this path will basically be appended to the paths you specified in step 1, and if there's a file there, it includes successfully. If it's not there, it fails, okay? And that's not so fun, all right? Okay, you know what the difference is. The third question that you will always have to answer in these IDEs, in these build systems, is about libraries, okay? So these are kind of pre-built binaries in many cases, DLLs, and you do this in a very similar way. You go into your IDE, like we go into Visual Studio, and I think, where do we specify this? General, okay. It's been a year since I had to do this stuff. Advanced debugging directories. The library directory, right below the include directory. You can go in and you can tell it where to look for binary files, okay? So that is important. With make, you use this -L to tell the compiler basically where to look, okay? And then in Xcode, you have another library search path right there below header search path, works the same way, okay? The final thing you have to remember to do is tell it which libraries you want. There's this notion here, a repeating pattern of tell it where to look and then tell it what you want. You will mess up one of these 4 questions as you try and link things on future homeworks and perhaps even on this homework as you try and get GLM working. I think we had some students with issues on that. And so that is what you need to do. If you mess up one of these questions, you'll get a unique error kind of hinting that you've messed that question up, okay? When you want to tell Visual Studio, for instance, which libraries you actually want, you go into your settings, like normal project, and then the properties, and then you go to the linker, because the linker is what actually is thinking about, okay, what libraries do I need to link in to your finished binary? And you can go into additional dependencies, and you can actually write things like, I want SDL2, okay? I want SDL2, mixer, okay? These are the kind of things that you'll be doing, and when you get to some of the harder assignments, when you start running into these build issues, I can't build, what's this error mean? I hope you'll come back to this, okay? In Make, you've probably seen this before, okay? In your 280 or 281 or 482 assignments, whenever you have to link against a binary with a specific name, what you do, and this looks really funky, you put dash lowercase l, okay? And then whatever comes after that is the name of the library you want, okay? And I always think like, oh, it's the library's name is LSDL2, right? No. The dash L is a command, and there's no space between the command and the actual value you want to feed to the command. It's kind of interesting, all right? It doesn't usually work that way in other programs and libraries, but on Mac, the situation is a little bit spicier, okay? Xcode is a very, very fun program. And what you have to do is you usually have to download a separate framework, and you can find these things on GitHub, but you download framework files, and then in your project settings, you click on this little blue thing on the left bar. You then get all these options. You go to build phases, and then you can drag in your frameworks, okay? Or click the plus button to go identify them on disk. You do these things, and hopefully they will build, okay? You also, I think, maybe need to add them in general, or you can check to make sure they're there in general. If your frameworks suddenly start failing, like it was working and now it's not, what's going on? I have a script for you to run that is, it tries to fix this, okay? This is a script you can download, and if you run it in the terminal, it will actually search through your entire project. You put this file at the root of your project, you run it, it searches through your project, finds all of the frameworks, and then runs a code sign operation on them to try and fix some things up that can break, okay? It's a pain in the butt, big pain in the butt. But this is a way to fairly consistently get Xcode libraries to work, okay? In the future, when we get to SDL, we're going to talk more about how to get DLLs copied to the right place. What is a dynamic library compared to a static library? Any idea? The names kind of hint as to what's going on here. Yeah.
The static library gets all compiled and included with your code at compile time.
Yep.
The dynamic library gets loaded into your code at runtime.
Yes. One really good way to know whether your program has a static library problem or a dynamic library problem is the question of, does my program start running? If my program starts running and then immediately crashes after, that's usually a dynamic library problem. It couldn't find something that it needed. If instead it just won't compile, it won't run at all, it doesn't even leave the editor, that is a hint that a static library is missing, okay? And this did show up on the final exam. So compilation process and these 4 questions are a big deal. You get these memorized and you will suddenly be able to include C++ projects like you haven't been able to in the past. But basically, if you have any DLLs, you need to get them to the location of your final executable before you run that executable. How do you do that? Well, one way you'll do it, we'll show you how to do it in the future, is to go to your build events, go to post build event, and you can actually run a command in here after the build is complete to copy your DLLs to the right location, okay? It is very nitty-gritty stuff, and it's not always that exciting, but once you get better at it, your powers will dramatically expand, okay? So you can see here a copy command, and here we're copying a DLL to the output directory where the executable will be able to find it and use it, okay? In Xcode, you have to configure something called the R path, the runtime path, I believe it's called. Anyway, categorizing these issues, there are two common types, and this is something you really want to know. There are compiler issues, and then there are linker issues, okay? The compiler issues tend to look like this. They're very, very associated with source code, and they'll often say something like an identifier, okay? Weird function call. We have no idea what this weird function call is, okay? Like, we can't find it. We can't do anything with it, okay? You'll find something like this. You'll find it when you go to compile, or even before you compile. It will tell you about this. You'll see red things in your console, okay? Compiler issues tend to occur very early in the build process. Linker issues tend to come later, okay? After the compilation is kind of finished, we're linking everything up, and unresolved external symbol, okay? If you see unresolved external symbol, you're almost certainly dealing with a linking issue. The compiler knows what you're trying to do. It can find the declarations of everything you need, but it's kind of struggling to find the definitions. It can't find the implementation of that function, okay? So, or that class, or that variable. And so, linker issues and compiler issues, if you know which is which, you can dramatically expedite how you solve this issue, how you debug it all, okay? And this tends to happen way later in the build process, okay? You might also see these little error codes, right? LNK, link, okay? That gives you a strong hint as to what's going on. In order to fix these, if you have a compiler issue, you usually have to adjust your IDE's header or include directories, like we just showed you. Very often, if it can't find a function that you want to call, you say, well, I'm including this thing, I should be able to call the function, right? No. Okay? If you mess up those include directories, if you're not telling your compiler where to look for stuff, then it's going to get confused. It's going to be like, I don't know about that call. I can't find it. I can't do anything, okay? So you usually have to play around with your header and include directories, okay? And then, of course, you have to tell it what to include and where, all right? Let me give you an example, okay? I'll give you a quick example if I can. Where is that file here, desktop, okay? We got our GLM folder right here. And let's go in here real quick, okay? I'm going to go in and say, hey, show me where this main file is. I think I can do that, or maybe I could go here, right-click, open file and file explorer. Here's my project, okay? There's my main.cpp file. I'm going to put my GLM right here. I'm not saying you should do this. In discussion section, they had probably a much better, cleaner kind of folder structure. But I'm going to put GLM right in here on disk, and I want to include it. So can I do that? I'm going to go include, and then hopefully when I start to type here, my IDE is going to try and help me out. Okay, it's going to look for things. So I start typing GLM, and look at that. It already found the folder. Okay, I can bring the folder in. And then I think, do I need to do this? I think this is it. Oh, that's nasty, isn't it? Okay, what's the problem here? Cannot open source file, blah, 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 blah. Why can't you? Oh, yeah. Yeah, it's not a thing. It's not a thing. I forget exactly what you need to. Is it glm.h? Is it in here, maybe? Where is this thing? Where's that glm.h folder?
No. You go in one further, the GLM.
Let's see.
Yeah, here and there.
Yeah, there we go. It's glm.hpp. So glm.hpp. Ooh. Okay. And is it going to be happier? Hello? Hey, why can't you open it?
Yeah, I think there's one GLM too many in the
It's interesting because,
that seems right.
Yeah, this does seem right.
That's right.
Let's do, yeah.
Now it works.
What?
IDEs are funky.
Welcome, welcome to the world of IDEs. Huh? When they're working, they're great. But anyway, this is kind of a nasty, look at this. I mean, isn't this hideous? We can use data types now. I think we can do GLM. Oh, yep, we got all these great functions we can call. We can take the absolute value of something, right? But isn't this file path nasty? So how can we deal with this? What if I want to do this? I really want this. Include GLM.
Autocomplete, why?
I want to do this. Doesn't that look way nicer? Way nicer, right? Well, you ask yourself, why do I have to do all of this? And the reason is because Visual Studio, by default, the only place it's going to look for headers, is right here where the root of our project is, okay? So it has to go quite a ways, all right? You have to literally look at this and follow the path down to get to that thing that you want. And so what we can do here, though, is we can probably specify, hey, I want you to look in this folder, in this subfolder. So let's try that out. Let's go over here. Let's go to project. Let's go to properties. I haven't done any of this in a while, so you'll have to forgive me. Include directories. And let's say, you know what? Visual Studio, I want you to look in, what is this? Project dir, okay? So I type project dir, and I automatically get this nice absolute path right down here telling me I'm doing the right thing. And then I want to do GLM. And what is our path, actually? I have to take a quick look.
The GLM version number /GLM.
Yeah. Ugh. Nasty. Okay. GLM, and then was it 9.9.8? Is that right? Okay. GLM 9.9, GLM, 0.9.9.8. Okay. 0. So it's not finished. When's it going to be finished? Okay. I press OK, apply, and now if we look in here, is this what we have? Oh, wait, did it go away? No, here it is. Okay. I think I need to put a dash in here too. Is that it? Apply. Okay. And then we'll give it a chance to kind of think about it. Include. Okay. GLM. Okay. Okay. Wait a second. I need one more GLM, huh? Okay. Let's get in here. Include path. Oh, yeah, you're right. I need one more GLM. Yep, that's right. So, okay, add that in there. Okay, apply.
GLM.
And then I have to write one more GLM. And then I can do glm.hpp. Right? Okay, but the takeaway here, thank you all for helping. The takeaway here, though, is that you can tell your build system where to look for things, and that really has a big impact on how your includes work, how your build process will find stuff. And if it can't find stuff, don't just bang your head at it. Look at your file system structure and where things are, and you can usually figure it out. Okay? Yes?
This is a minor question, but I know when I worked in Ubuntu, it really absolutely hates the backslash like that. So
Oh, yeah.
is it just a Windows feature that's like you can use the backslash?
Does that work too? I think that works too.
No, that is
Yeah.
the standard, but the other one is...
Yeah.
Okay, because that's
Does
what
this
I
one work?
expected to work, but like when you do it that way, I'm like, is that just a Windows feature where it just works like that?
Either way works.
Yeah, I'm just
Hold
so
on.
used to Ubuntu from 281. It's like, I refuse to work. I do it the other way around.
GLM absolute value of negative 498. Let's see here. Okay, run it. Yeah, it works.
Oh, okay.
Yeah, well, yeah.
I guess it's a Windows feature.
Yeah, who knows if it's going to work in
On
Xcode or
Linux,
Make.
I don't know if it works.
Okay, yeah, so
Linux requires the direction.
Gotcha. Anyway, so keep all these things in mind. That's the big takeaway, right? You're going to have to play around with your settings quite a bit in this course to get things installed and working. But once you do, you can move forward with the logic of the assignment, and that's usually really satisfying. It's also kind of actually a bit satisfying to fix these issues. Just like, yes, okay, I'm feeling it. I know what the build process really is. Anyway, if you ever get a linker issue, like everything includes, there are no red squigglies, right? That suggests you got a linker issue. And you're going to have to go in and adjust your IDE's library directories config, right? We need to make sure they're going to look in the right folder and find the right things. You might also tell your IDE, hey, I want this library, go find this library and link it, okay? Not enough to tell it where to look, you have to tell it what to look for, okay? And if you do these things, you'll be in a good place. This is going to be very exhausting for you. Chances are it really saps your morale. But you will probably feel pretty good as you get better and better at this, and eventually you'll integrate things like Box2D, and it'll be easy peasy, okay? Then the whole world opens up to you. A quick story, like I remember, like pretty vividly, being like a high schooler and trying to learn C++, and I would go hear about this cool library like SDL, and I would try and integrate SDL, and I would just fail for hours, okay, with weird issues and errors, and I couldn't figure out how to deal with it. And all the YouTube tutorials would say, hey, click on this, then click on this, then click on this, never explain why. And it was awful. And I gave up on C++. I never got an SDL program running until I think a couple years ago. Did anyone else have a similar experience with C++? You're trying to integrate stuff, you're trying to get things to build, and it just won't build. This language stinks. A big part of the kind of initial frustrations of C++ is that the compiler and the linker are they're very basic. They do certain things, and they're not going to do anything like Python to help you, right? And so that's just how it goes. But soon, you're going to be that really cool teammate that everyone goes to help solve their build issues, and you're going to feel really, really cool. That might sound annoying, but I'll tell you, people really appreciate when you can fix the build issues that they've been stumped on for 2 or 3 hours, okay? And if you're on an industry team or a grad school team, talk to our game engine architecture students at StarDoc, okay? They'll tell you stories, and they're really glad they know how to link all this stuff. Anyway, it allows you to integrate all the weird projects you find online, and it makes the entire process of building stuff way more fun, okay? So I hope you will. I hope you look forward to it. Okay. So does anyone have any comments or questions on this topic? This is a topic that I think is a little bit out of place in the course because it probably should come during homework 5. Because homework 5 is your first huge, like, oh my goodness, integrating like 5 different things that have headers, they have dynamic libraries, and they have static libraries. It's like, oh goodness. But anyway. I hope you'll return to this if you ever have any issues like that in the future, okay? All right, any comments or questions? No? Okay, so what I want to do now is I want to kind of walk you through some kind of very basic ideas, if I can, when it comes to game loops, okay? When it comes to building that first project. So if you haven't started yet, I recommend you do the same things that I just did in this Visual Studio project a bit earlier to get it running, okay? Just get something running at first, okay? Get GLM integrated like we just showed you how to do, but there are a few other things that you want to get hooked up as well. And if you don't do this, you might be in for a bit of pain later, okay? One thing you're definitely going to want to do is going to want to go to Project and then Properties, and you want to go to C++. If you go inside, there's a little Language tab, and I believe it asks, like, what standard do you want to use for C++? This course uses C++ 17, and you're going to need to specify this in Make, which you already saw, in Visual Studio, and in Xcode. But you want to make sure that C++ 17 is being used. I believe some of the helper files you're going to receive later in the course require C++ 17. Okay, so it won't build without you fixing that. Now, what other things do you want to think about? You might want to go to Project Settings and turn on the warnings. So you can go to, let's see, Project Settings, C++. You can go to, what was it? It was a language. No, it was general. Okay, so you can go to general, and I think it's possible to turn on the warning level. I recommend that you kind of roll with the heaviest warning level that you can. I think my final project is actually, the staff project is actually level 3, but you might want to jump into level 4, which will point out even more things that could cause you pain and allow you to fix them. Some libraries you just can't alter, and they will generate warnings, so be ready for that. When it comes to creating that main file, remember, you want to go down to the source files folder, and you want to right-click, go to add, go to new item. You can create a CPP file, call it main. You're all good to go. But eventually, you're going to want to create new classes, okay? C++ is a little bit odd when it comes to how you create new classes, what the best practice is, okay? When you create a new class in C++, you're going to end up with 2 files, not 1, okay? In Python, you just end up with a new .py file. With C#, a new .cs file. When you right-click on source files and go to add, you're going to find a nice little button called class. I want a new class. And let's call this something like engine, okay? As you type engine, you'll see that there's engine.h and engine.cpp. One of these is a kind of a declarations file, okay, the .h. It's where you tell the rest of your program what exists. And then you end up with a .cpp file, okay? .h file is down here, .cpp file is down here, okay? In .h, we're kind of designing what we want, okay? We're designing what we want to have, and so we can go and add some public members. We can add some private members if we want. Right now, though, what I really want are just a couple functions to run. So I want something referred to as a game loop, okay? So let's go ahead and create a function here. It's a public function, so I can call it pretty easily. It's going to be void, let's do game loop, okay? And I think that is all we need right there, okay? Now, this game loop function, I think we can now call it, okay? We have to include that file, but let's go ahead and include engine if we can. There we go. We can now create an engine. So we go engine, let's just call this engine, lowercase. Then we can go engine.gameloop. We can call that game loop function, okay? What's going to happen if we run this right now? I want to point out that actually there are no red squigglies anywhere, right? No issues, no problem. No compilation concerns at all, okay? We do have a green squiggly, okay? If I try and run this, we run into those linker issues, unresolved external symbol. This means that we've declared that game loop function, but we haven't actually provided its guts, its details, its implementation, okay? We have a declaration, but we do not have any definition to define what game loop actually is, okay? Here's something that's really nice about IDEs. I think Xcode gives you this ability as well. In Make and on Linux, I have no idea. For those of you on Linux, what are you using to edit your code?
I'm actually using CLine IDE, and I've integrated my Make files into
Okay, got you. CLine. I heard that's a good one. You can right-click on game loop, go to quick actions and say, hey, let's create a definition of game loop. And boom, right there, it just created it for me, okay? Now, does anyone know what this is right here? You all know what void is, right? Void says there's no return value from this function, okay? But what is this right here?
That's the name of the class it's a part of. You're saying that this is void game loop, but you're saying this is the contents of the game loop function from the engine class?
Yeah, that's right. Let me do a quick experiment. We have this class right here, which has a game loop function, but I could come out here, and I'm pretty sure I can do this. And I can say, well, there's just a global game loop function, right?
Yes.
So when you go to engine.cpp, there's a question. When you're writing this game loop definition, is it going to be for the engine's game loop function or for the global one? Okay? And in this case, you use the name of the class and the scope operator. Okay, the scope operator, I believe that's what it's called, is this double colon. Okay, you'll probably see it quite a lot during this course. It's basically saying, hey, the game loop within the engine. Okay. Anyway, let's go in and get rid of that other game loop, which we do not need. Okay. So now we actually have a function that we can call. When we run our program, it should build and it should run successfully. But that's not really a game, is it? So when we run this function, we want to do a bunch of things repeatedly. We want to only end when the user's ready. So what should we do? Well, what we can do is we can say we're going to have an infinite loop, okay? Or something like it. Let's go ahead and create a Boolean. Actually, you know what I'll do? I'm going to go into the engine, all right? I'm going to go into this engine, and I'm going to say, hey, we're going to keep some state in here called bool, and let's say, running, okay? And I'm going to start this as false. I think I can do this. There we go. It starts as false, or maybe we're going to make it true, okay? Every single frame, we're going to check, hey, if we are currently running, all right? If we are currently running, then we're going to keep going. Otherwise, we will end. So what do we want to do now? Well, we probably want to get some input, okay? So do you remember how to do that? Standard cin. How long has it been since you used cin? Anyone? Like a while?
2 years.
2 years. Which course?
I think last time I used it was 281.
281.
2 days.
2 days. What were you using it for? 183. Oh, yes, of course. All right. So what I want to do is I would like to get a message from the user, and cin is a pretty standard way to do that. I want to put it into a string. So let's go ahead and get a string, all right? We'll put it right up here. So we're going to use the string data type, std string. By the way, have you noticed how I keep writing std, : right? Usually you don't have to do that, right? Because you probably wrote something like using namespace std. Now you can just deal with the string without any std. That's awesome, right? Well, yeah, it's fine. It's probably fine, but there's a chance that by bringing everything from the standard header space in, you might have a conflict with something like Box2D or another library you're going to use. Maybe GLM has its own string, and this is going to blow you up, okay? So I tend to not use it. std : is not that long to write, and it gets the job done, okay? So std string, let's go current message, or how about user input, okay? And we're going to use cin. I forget which direction this goes. Is that it? Is that how it works? Yes, but we need IOStream. Include IOStream, because cin is in IOStream, so now it's available to us. Great. And all I'm going to do, basically, is I'm going to wait to see if that user input is equal to quit. And if it's equal to quit, I'm going to set running equals to false. We'll break out of this loop. We could also put break here if we wanted to. And at the end, we'll do a message so we know it has ended. Okay. And standard end line. Okay. So let's see what happens. So I can run this program. It doesn't end. I can keep pressing enter and sending stuff in. And then when I write quit, the game ends. Okay? So not too bad. But this is kind of, sort of messy. Okay? I want to clean this up a little bit. When you think about a modern, typical game loop, it tends to be structured a bit differently. If you go to GameEngine.h, we have our game loop, but within this game loop, we have 3 discrete steps, and they tend to go in a certain order, okay? So we're going to have a step called input, all right? We're going to have a step called update, and we're going to have a step called render, all right? And I think it doesn't like input because this is like a keyword or something. No, actually, I think it's fine. Let's go ahead and create the definitions really quickly for all of these functions. And with the IDE, we really can do it very fast. All right, just like that. Boom, 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 quick, boom. Good, okay? I do like Visual Studio. It's a bit clumsy and bulky. I think Xcode just isn't as good as this kind of stuff, helping you quickly knock out code. What we're going to do is we're going to write a game loop that kind of looks like this, okay? The idea is every frame of our game, we're going to collect input from the user. We're then going to use that input to update the state of our game. That could mean moving the player. It could mean updating the enemy locations, running some enemy AI. And then once we're done computing and changing the game state, then we render that game state to finish everything off, okay? This is a very, very typical way to go. And so I'm going to move this, some of this stuff, into input. Now, in update, I actually want to use it. I've got a problem here, okay? I've got a big problem. So we got this beautiful, super easy to read game loop, okay? You look at that, very nice. However, in input, I collect the user input, but in update, I want to use it. So what do? I can't get this variable. How do I get this variable over to my update function? Any idea? Yeah.
You can just declare it in the header file.
Yeah. Or specifically where in the header file? Yeah, absolutely. So one way to think about this piece of data is that, you know what? Many different parts of our engine probably want to know what the user's input was, maybe. So what we can do is say, you know what? This is not going to be just a local variable in the input function. This is going to be something that we actually put into our engine class. So along with the Boolean, running Boolean, you know what? I probably got to come in here and do include string. I think I do need that. Right? We now could use this anywhere in all of these engine functions. It's available in all of them. So right here, we get to the input and we put it into that variable that our engine has. In update, we check to see if it's quit, and if it is, then we go ahead and set running to false. You know, we do a render of the game state. We're not really doing any of that yet, though. And then, yeah, if running is false, we exit. So what kind of thing should we do to keep track of our location? Well, one thing we could do is we could have a variable that tracks our current position, okay? I think we could even make this a GLM variable, couldn't we? We could try it. So let's go include, and then we'll try our crazy GLM path again. Nope, the simple one will work for us. Let's go ahead and get GLM in here. How can we represent our position? Let's say maybe I want to do an IVEC2. What on earth is an IVEC2? In C++, there's this like overarching fascination with making the shortest data type names and function names you could possibly find. So like the function names like A2I, have you ever seen that one? Like A2I drives me crazy. Okay, or S2I, I think that's another one.
Yeah, A2I is for C strings, S2I is for C++ strings.
Got you, okay. And I can never remember them. In general, the parts of the name are trying to tell you something. So this I means integer, okay? The vector means you've got basically a tuple, okay? It's a 3D or 2D point, or some point of some amount of dimensions. This is not the same as an STD vector, which is kind of a dynamically resizing array. And then it's 2. So this is a 2 tuple. You've got a vector of 2 items. This is a 2D point, okay? An integer 2D point. Let's call this player position, okay? And there we go. Let's see what happens. By the way, I've written a lot of code, so actually, I just want to do a quick message. Cout render here, okay? And let's see what happens. I might have an undefined issue. Maybe. Am I gonna have it? No, it worked. Okay, so I press something. It says render here, render here, render here. No matter what I press, and then I do quit. It renders, and then we're out of here. Okay, excellent. So what should we do now? Well, we should render our current position, right? So player is at, and then we can do our coordinates. So where are we at? The player position dot x, okay, and then we'll add a little comma in here, and then player position dot y, and then we can add a little end parenthesis in here, and then end the line, okay? We want to be able to move, though. And in update, we can do that. So if the player enters quit, that's fine, we'll just end the game. But if they enter something else, so user input is equal to, how about east? Okay, we'll go, let's do this. Player position plus equals GLM IVEC2, and then we'll do 1, 0. So we'll move to the east, okay? Similarly, and you're going to get to see me do some copy and pasting. Be careful about that. South, how do we move downward? Does anyone know? In our special coordinate system?
Is it 0, 1?
Bingo, yes. So the number, your Y position actually goes up as you go down. Why did you do that, Austin? We did that to maintain parity with how SDL manages its coordinates. And so that is why. You will get used to it. In GameMaker, the engine that I first learned to program games on, that's how it was as well. Okay, it wasn't intuitive there, and chances are Mark Overmars did that because that's how SDL was doing it. Anyway, so let's go west. If you type west, we're going to do the -1, 0, and then if you go north, we're going to do that by going in -1 and a 0 on the x-axis. Okay. So we've written some code, so we should definitely... Oh, did I mess something up? What's that? Oh, yeah. You should have let me just do it, and then you could watch the chaos as I squirm to try and figure it out. Okay, so... Oh, you know what's interesting? They're asking me for a decision, but I don't have the render, the initial render. So often, what you actually have to do is you want to render the first frame. In fact, I think in your engine, you have to do a render first before you enter the game loop. And we do that because we really want to help our players just have the information, the starting information, so they can make that decision. So there we go. We've set it up. This code just looks really pleasant to me. I like it a lot. The player is at, oh my goodness. Okay, I want you to tell me right now what I messed up. Because I just made a big mistake that I told you about earlier. In fact, did the editor tell me that I have an uninitialized variable? I feel like it should have. Maybe I'm not.
It should be in the warnings. I don't think it was in the
Yeah, where are they? View. Where are the warnings?
If they're on the terminal, I believe. Is the change mode of the terminal.
Oh, here they. No warnings. What?
Oh, is it based on the file you're on?
Yeah, it is totally fine with this. That's a bit spooky. But anyway, IDEs. Is there, I can't remember, C# lets you do this, but can you define the initial value in here? GLM, it would be IVEC2, and then it'd be 0, 0. It's going to let me do that? It's a pretty fancy feature. Let's go. All right. Very exciting. And good. I should also see if I can set this to an empty string. We'll be okay with that. I think in earlier versions of C++, it did not like that kind of thing in a class. All right, so we are at 0, 0. I'm going to write to east, okay? And I'm going to the right, okay? I'm moving, so let's go, no, I can't do up. Let's go to the north, okay? My y-coordinate is getting smaller. That's what happens when you go to the north, and then I quit, and the game ends, okay? And so you can imagine that as you do your homework 3, this update function in particular is going to get a lot fancier, okay? You're going to have more functions in here. You're going to have a function maybe for the enemy AI, right? Compute the new enemy AI locations. I think actually the way that it is you have a list of actors, okay? In fact, I'll show you the helper file right now. You can go into Game Loops and Text Adventures, go down to the dependencies. Let's grab map-helper.h and let's actually bring it in, okay? I can just copy and paste it in. I'm going to go, let's go new file, add new item. I'm going to call this map-helper.h. Okay, it is a header file, so hopefully it'll be there. Yep, it is. And I'm going to paste this all in, okay? Yeah, all right. So now we should be able to get it up here if we want. Let's go include map-helper.h. And In map helper.h, you're going to have this actor structure, okay, which you should just use. And we're also going to have a bunch of strings that you can use. So for instance, the game start message, we could start our game, that initial render. We can actually do something like this maybe, okay? Let's go ahead and print that game start message and see if it shows up. Okay, boom, there it shows up. Fantastic. And in this map helper.h, you'll also find the entire map for the game. It is right here, okay, hard-coded map. So you can iterate through this array if you want in a for loop, probably a double for loop. And you can print out this map or whatever portion of it you need to. In this vector right here, you have a vector of actors, hard-coded actors. This has all the enemy AI in it, all of the friendly AI in it, and at the very end, it has you, the player. If you detect that you are updating the player actor, you need to then go get information from the player to move them properly, right? And you can check the name of the actor if you want to get that. You can explore the actor's structure, which is coming up here, actor name, blah, 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 blah. This is not a super hard assignment, but hopefully, if you've been a bit rusty with C++, you'll start to feel a bit better, okay? One thing that can help people, be very specific, but if for some weird esoteric reason, maybe you're super used to C#, but for whatever reason, C++ compiler is just not liking the way you're describing something. An example, I swear in the past, I wanted to do this, and it's obvious what I want, right? But it just didn't work. The compiler would yell at me. You can often take that line of code, put it into something like an AI assistant, and they might tell you, hey, you know, you're trying to do something that's from C#, you might be able to adjust it this way, and then the compiler will accept it. Or you can bring in office hours, and we'll try and help you there, okay? Anyway, so do you have any, we're about 5 minutes to go, and then we got 2 hours of office hours. Does anyone have any questions or comments? I hope you enjoy these assignments. I think I really enjoyed making the AutoGrader assignments. It's fun to get back into C++ and to try and beat the instructor performance times, which is not super hard on this one. Yeah, I hope it gets your confidence up, you get stuff building, and that will take us into homework 4, which is a little bit more gnarly, okay? I think next week we'll start talking about some things that might be of use to you, like smart pointers and some other stuff. As your project grows in complexity, we need to learn a bit more C++ to manage that, okay? All right, any questions, comments? Then I will see you on Monday, okay? A reminder, I'm going to try and fix the Xcode situation tonight, but don't worry about it too much. If I can't get it to work, you're just going to all get a bunch of points, okay? So, anyway, wish me good luck. See ya.
All right.
Are you gonna go right now?
All right. I'm going to step out for just a little bit to use the restroom, but then I'll be back for the full office hours. Okay.
And then I was also hearing that apparently we can have smart pointers being used later on.
Yeah, you can use any of C++ 17.
Yeah, I guess that one's a bit new because classes like 280 and 281 ban smart pointers from being used.
Yeah, I think in those courses there's a heavy focus on like understanding what memory is like doing and what's happening. But like you're beyond that course now, so I don't really care that much. I just want I want you to be as practical as possible on this project, while still using some of the requirements I have, like not using CMake. Like that's not super practical, but okay. Everyone online, thank you for joining us. I hope you have a great weekend. Good luck on the assignment, and I will see you later. Bye bye.